I'm Kingshuk, and today I'll be presenting in front of you our project Feedio, which we have built for the Neo Polaris hackathon. So, Feedio is basically a decentralized and reliable price feed platform, right? So, one of the key needs of a decentralized finance platform is that access to like reliable price data of the various cryptocurrencies on which they are basing their services, right? So it is really a key component. On the Web 2 side, you have a lot of price feed APIs that can be accessed, but this project was aimed to simplify the access for smart contracts so that don't need to like spend a lot of gas and make Oracle contracts, Oracle calls to retrieve those prices. The prices can be directly retrieved via the smart contract that we will be providing. So the access is sort of directly from the smart contract layer, right? So this simplifies the development of a lot of DeFi solutions, right? So this project involves multiple pieces. So I'll sort of have a high level diagram that will explain each of those aspects, and then we will go through the details of each of them, right? So this is the overall scheme of the project. As you can see, there are a number of modules. So on the right hand, I'll start with the extreme right hand side. So you have these various price feed providers. So when I say price feed providers, these will sort of fetch the data from various other sources, make sure that they are reliable, normalize them, and then sort of pass it on to the primary app. So all these set of apps are on the Web 2 layer, right? Now, another interesting point here is that we have developed this solution as a platform. So what that means is that not only I will be responsible or we will be responsible for providing the price data. Anyone who thinks that they have a solid access to price information and they can provide it reliably, the platform sort of facilitates incorporating those services as well. And this will be the responsibility of the primary app to aggregate the data across these various providers. We have weightages based on their reliability and uptime and all those details. And then basically what happens is periodically it will keep on writing that data to a common aggregator contract, right? So it will at any point of time have the like near real time data of the prices of the supported tokens and cryptocurrencies, right? Now of course, as you would all be aware, that writing data on chain is an expensive process, especially for these kind of use cases where we have to do it on an ongoing basis. So what we have done to sort of offset those costs is, for the access part, we have provided an NFT that you can mint. And if you have that NFT, or rather the smart contract from your uh, where you will access our price feed, they should have that NFT, and the cost will be significantly less if you were to directly retrieve those prices by yourself, right? So this presents an overall view of the project. Now I'll move on to the individual pieces, starting with the price feed providers. So as part of the project for completeness, what we have done is we have provided two independent price feed providers which are aggregating data again from different sources, right? So as you can see here, this is the first feed. So this is getting me data of these tokens. You have the Neo Gas, Bitcoin, Ethereum, Binance, Neo, of course, and Matic, right? So how this data is retrieved is, again, for this provider itself, we are aggregating data across CoinMarketCap, Binance, and CoinGecko, right? So that itself makes it reliable that there is no dependency on a single API source, even at the provider level, right? So this is one of the key aspects of the provider. Now we have another provider that is sort of retrieving similar details from Chainlink. So Chainlink again is an Oracle service that is primarily that primarily runs on the Ethereum and few other blockchain platforms. So they also have an elaborate ecosystem where price feed data is updated. So what we have done is sort of created a bridge to retrieve those data, normalize it against the two providers, and store it across so that you have like reliability from various sources again, right? So and then of course, like when I come to the when I come to the aggregator app, so here you can see that we are aggregating responses across these different providers. Also, like we retrieve the current on-chain prices, and see that whether there is a significant update or not. So this happens on a periodic basis. The scheduling can be adjusted based on the configuration. So right now on the testnet we have kept it at like 20 minutes, but obviously when it goes to the mainnet it will be roughly a minute or even less than that, right? So this step here basically compares the currently written on-chain price and the data that is coming from the different providers. And if there is a significant difference, so again that is something configurable, the prices are again written on chain to the same contract, right? So this is an ongoing process that keeps on happening. And as you can see, the aggregation steps are there, the on chain prices are retrieved, and then the data is pushed to the smart contract, right? Expired. So I'll show a better representation. So this is the detail of the NFT contract that you've deployed. And as you can see, like there are currently two holders of the subscription access pass, and there is an NFT representation. And along with that, there is a expiry timestamp, right? So as soon as you like make the payment for minting the NFT, sort of the expiry time sort of gets set against the NFT itself, right? So all that can be validated on chain, and the data can be provided to the subscriber, right? And here is so I've created a simple UI so that you can view the data that the price feeds are providing, and all this data is coming from the chain, the smart contract itself. So it is all the data is on chain. We are using RPC clients to retrieve that data and display it. And here we have a functionality to connect with the wallet, and we will sort of add the capability to mint it directly from this UI itself, right? And obviously, like going forward, as and when we keep on adding more, let's say currencies supported, as well as tokens, as well as various other functionalities, we will keep enhancing the app, right? So on that note, I wanted to highlight the economic model. So of course, I mentioned it briefly. So we have optimized the cost, and of course, there is still scope of further optimization. But at the current rate, the expenses are roughly 650 gas per month, right? Currently we have kept the NFT cost at 30 gas. So that will give you access to roughly a month to the price feeds. So it typically costs about 1 gas per day for getting real-time live data, which would be like pretty like expensive if you were to do it on your own and retrieve it on an ongoing basis, because the Oracle costs itself are zero point 0.1 gas per call, right? And the break-even point would be like roughly, let's say 20 to 22 subscribers are using the platform, then that would be covering the cost on an ongoing basis. And of course, after that, we can like adjust the prices to make sure that it is convenient for everyone, and the platform can itself grow to add more support for tokens, as well as like making things more reliable and so on, right? So these are some of the roadmap items as well. So we would want to move most of the web 2 or the non like the off chain aspects also to the smart contracts, including the aggregation and the reliability determination. So currently the costs sort of prohibit that, but as and when the economics of it work out, we'll definitely move things more towards the on chain. And of course, like we'll keep on working on like improving the reliability itself, as well as expanding the support of uh, the currencies, the tokens, the even the like the fiat currencies across the various sources. So we'll keep working on those aspects, right? So yeah, thanks a lot for your time. I hope you liked our project. Thanks. Bye.